All right, we're going to begin our review video for Chapter 7, Section 9. Chapter 7, Section 9, and our learning target for today is to find dimensions, surface area, and volume for similar solids. Similar solids. Well, we need a definition of what a similar solid is. So, a similar solid are solids that have the same shape, and their corresponding lineal measures are proportional. Not equal, but proportional. All right? So let's jump in and look at something here. These cones are similar. What is the radius of cone A to the nearest 10th? All right, well, the radius of cone B is 8. The height of cone B is 12. Comparing that to 7 for a height here and a radius of unknown. So I'm going to say, well, X is to 7 as my radius for the bigger cone is 8, and my height for the bigger cone is 12. So there becomes my proportion. I'm going to do a little bit of reducing here first. 4 will go into 8 2 times, 4 will go in there 3 times, so I've got 2 over 3. And I'm going to do my cross product here, my cross multiplying. I've got x times 3, or 3x, is equal to 7 times 2, which is, of course, 14. X then is equal to 14 divided by 3. So 14 divided by 3. 3 will go in there 4 times, that'd be 12. 4 and 2/3. So the new radius, the radius for A, is 4 and 2/3, or 4.66, with a bar over it. All right. Do the same thing here, and we'll check. The cones are similar. What is the radius of cone B to the nearest 10th? Well, you can see that cone B, I think they mean to say the height is the unknown part here. So I'm going to say, well, the height of 10 is to our height of our unknown for cone B, as 4 is to 3 for the two cones. As I do my cross multiplying here, I'm going to do 10 times 3 and get 30 is equal to 4 times h. Divide both sides by 4. And I'm going to get h then is equal to 30 divided by 4 is 7.5. So 7.5 would be the height of the cone B, 7.5. Okay, now surface area gets a little bit more complicated. When we deal with surface area of similar solids to similar solids, surface area, the proportionality is not based on the ratio of the sides, but on the square of the ratio of the sides. The ratio of the sides squared. And the volume is on the ratio cubed. So let's do one. All right, these rectangular prisms are similar. Find the total surface area of prism A. Well, we know the surface area of prism B, and we know two of the dimensions, one on A and one on B. So we're going to say 8 is to 12 squared, because we're dealing with surface area, is equal to our unknown surface area for prism A, as it is to 376 inches squared. Well, I'm going to do some reducing here before I square. 8 over 12 reduces to 2 over 3, so it's 2 over 3. 2 squared is 4. 3 squared is 9, so I've got 4 ninths is equal to x over 376. Now I'm going to do my cross multiplying. 4 times 376 is equal to 9x. So with my calculator, I'm going to do 4 times 376. And I get 1,504 is equal to 9x. Oh, yes, 9x. So now I'm going to divide both sides by 9. And I'll do that again on my calculator. And I get 167.1. So the new area of prism A, the area of prism A is 167.1. 167.1. Well, let's try it again here. You do this one, and we'll compare our answers. So stop the video and come back when you get it completed. These square pyramids are similar. Find the total surface area of pyramid A. Pyramid A, Well, I have 12 to 18. So I've got 12 to 18, two similar sides. That quantity, of course, squared, because I'm dealing with surface area, is equal to the unknown surface area for pyramid A over 1,188. Well, I'm going to do some reducing here. 12 over 18 can be reduced to 6. I'm sorry, I don't want to do 6. I want to divide both sides by 6. I'll get 2 over 3 quantity squared. So 2 over 3 squared would be 4 over 9 is equal to x over 1188. Doing my cross multiplying, I've got 1188 times 4 is equal to 9x. And divide both sides by 9. X then, I'm going to do this all on my calculator. I'm going to take 1188 times 4. That's equal to 4,752, and I'm going to divide that by 9, and I get 528 is the area for the smaller pyramid, which is letter B. So I think that is our correct answer. Let's do a volume one. A triangular prism has a volume of 12 centimeters cubed. Suppose the dimensions are tripled. What is the volume of the new prism? All right. So the volume of the new prism, so I'm going to go volume here, new, is 212 as the new dimension. Well, if the old dimension was 1 and I tripled it, it'd be 3 over 1 is my ratio. But, of course, this is cubed because it's volume, so we have to cube it. So V over 12 is equal to 27 over 1. V times 1 is V. 27 times 12 equals 324. So the volume of the new prism after the dimensions have been tripled is 324 centimeters cubed. 324. All right, here's another one. Do this one as practice and then come back and we'll check when you're done. A hexagonal prism has a volume of 25 cubic inches. Suppose the dimensions are tripled. What is the volume of the new prism? Well, I'm going to say 1 was the dimension of the old one. It's tripled, so it's times 3. Of course, I know volume means it's cubed, and that's going to be equal to some unknown over, I'm sorry, it's the 25 is the original dimension, so 25 over 1. I'm sorry, 25 over the unknown x. The unknown x. So cubing this, 1 cubed. 1 cubed is 1. 3 cubed is 27. 27 is equal to 25 over x. X times 1 is x. It's equal to 27 times 25. I'm going to turn to my calculator to do that for me. And I get 675 is the volume of the new pyramid. So 675, letter D. Thank you.